Okay, so good evening, class. Welcome to our MI class for this evening. We are going to be looking at one key topic, which is limiting factor decisions. Now, limiting factor decisions are short-term decisions. These are decisions that management take when they have scarce resources. Okay, now we are going to be looking at some elements that will help us to identify limiting factors. We'll be looking at how we can get an optimal production plan when there is a single limiting factor. Okay, at your stage, you're going to be getting perhaps two or three products, maybe two, three, or four products, all having to use maybe one material or the same type of labor, or maybe pass through the same kind of machine. And that would be the singular limiting factor. Now, when that happens, let's say the material that is supposed to be used for all of them is not enough to go round as everybody will want. How do we get the maximal use of that limiting factor so that we do not just waste it on items that will bring low profit or low contribution to us? So we are going to be using the limiting factor principle to identify it. Okay, by the end of this lecture, you should be able to identify some limiting factors. You carry out tests to identify limiting factor, then you also create an optimal production plan based on the limiting factor you have just identified. Now, one of the objectives of management is to make decisions about how to run a business. So decisions involving making a choice about what should be done between different options is inevitable. So now when we have a limiting factor problem, then we need to make a choice as to which products should be made given the available scarce resource. Now, how do you know that this is the limiting factor? Probably in the exam, the examiner at this level may tell you the limiting factor. And so you will use words such as labor is limited to so and so figure. Or perhaps you will say labor is restricted to XYZ hours. Or you might hear the maximum available materials is maybe XYZ quantity. Now that is a key to know the limiting factor. And so you'll be given just one limiting factor. If they want to go a step further to test you whether you can identify limiting factors, they might give you two or more factors of production. And they may tell you the same language, maybe materials available is not exceeding XYZ, then they can now say labor is restricted to XYZ hours. Now, how will you know which one of them is the limiting factor? Because if you don't know the limiting factor, you cannot proceed. Okay, what will you do? First of all, you need to bring out the demand. Look at the demand that is placed before you, maybe your sales demand. If your customers is asking you for 20 units of X, 50 units of Y, look at the available materials. Maybe they give you materials to be restricted to so and so amount. Look at how much material can I use to satisfy my demand. So if they ask me to do 20 units of X, how many material quantity should I use to produce X? How many material quantity should I also use in producing Y? When I add them together, the sum total is the results equal to what I have in store? If the answer is yes, that means you are not facing scarcity. It means whatever you require to do that job is already available. No scarcity. That is not a limiting factor. So let's say you require 100 kilogram of material X to do, material A to do product X, and maybe 50 kg of material A to do product Y. You add 100 plus 50, you have 150. And if you are told that you have 180 available and you need 150, it's not a scarcity. You have surplus to do the job. But what if you need a total of 150, but what is available is 115? You need 150, available is 115. That means there is a shortage. Now, whenever there is a shortage, there is a scarcity, and that is the limiting factor. Let's look at example LF1, identifying a limiting factor. Okay, we are told here a company manufactures and sells two products, product X and product Y, which are both manufactured using two different machines. So you see there are two machines here. Either of them could be the limiting factor. Okay? The time taken to make each product together with the maximum machine time availability and contribution per unit and demand are as follows. Okay, we are told here machine type 1, we have 10 minutes of machine time to use to make 1 unit. So in making product X will have to pass 10 minutes to make 1 unit. That will mean that 6 of product X will be required to be made in 1 hour. Product Y, to make 1 unit, it has to pass 6 minutes just to make 1 unit of product Y. That means in 1 hour, you need to make 10 units of product Y. Look at the hours available, 3,000 hours available for machine type 1. So you cannot exceed 3,000 hours, whatever your combination is. Looking at the same type of analysis, machine type 2, the X will still pass through machine type 2 for 5 minutes for 1 unit. Or it's as good as saying in 1 hour, 12 units of product X would have been passed in 1 hour. Now in product Y, in machine 2, product Y, 1 unit will spend 12 minutes in the machine. That means in 1 hour, 5 units of product Y will have to pass through the machine. Available hours, 4,002. And now look at the demand. For X is 12,000, for Y is 15,000. And now we are asked, what machine is the limiting factor? We need to know if it is X or Y that is the limiting factor. How do we do that? Now look at taking them in turns. You take product X and take machine type 1 and machine type 2 because we are looking for machine that is the limiting factor. What is our demand? Product X, we need 12,000 units. Product Y, we need 15,000 units. That's fine. Now it means that if 6 units of product X is passed in 1 hour, 6 units of product X is passed in 1 hour, and 10 units of product Y is passed in 1 hour on machine 1. How many hours do you think it would take us to go through all the 12,000 units of product X? Taking them 6 in 1 hour. So you look at it, in 1 hour, you've taken 6. In 2 hours, 12 would have gone. In 3 hours, 18 would have gone. In 4 hours, 24. Like that. How many hours will it take you to do the whole of 12,000 units? You simply say 12,000 units divided by 6 units per hour. It gives you 2,000 hours. So it means that for you to satisfy the demand of 12,000 units of X, you must spend 2,000 hours in machine 1. Using the same method, if you must satisfy the demand of 15,000 units in product Y, taking them 10 per hour, it means you need to spend 1,500 hours in machine type 1. So it means for you to do X and Y and satisfy the two demand, you must spend 2,000 hours in X, 1,500 hours in Y. You add them together, it is 3,500 hours that you are expected to spend. Total hours required of you is 3,500. But how many hours can machine 1 carry? 3,000 hours. So it means here that the machine capacity is 3,000, and you want to force it to do 3,500. It's not possible. That means there will be machine breakdown. Machine can only take 3,000, and that means the remaining 500 is a shortage of hours. So that 500 will not, that you will lose. It means you cannot satisfy your demand. That means machine type 1 having a shortage of hours expected, or the hours required, hours available rather, having a shortage of hours available to meet the requirements is the limiting factor. Now let's look at machine 2 to really see that machine 2 is not the limiting factor. Okay, product X and product Y, we said 12,000 units and 15,000 units. But in machine type 2, product X need to spend 12 units in 1 hour. And product Y need to spend 5 units in 1 hour. How does it translate to the number of hours that will be required to do the whole of the 12,000 units and the 15,000 units? We'll simply say 12,000 units of product X divided by 12 units per hour gives us 1,000 units that product X will spend in machine 2. Using that same analogy, product Y will spend 3,000 hours in machine type 2. So when you add 3,000 to 1,000, you have 4,000 hours required. But what does the question say the machine hours available? 4,200. So it means the machine is saying, I can work for 4,002. But you are now saying, For my product, I just need only 4,000 hours. The extra 2 hours is surplus for you. So that means machine type 2 is not the limiting factor. Machine type 1 is the limiting factor. Now you see how you can identify limiting factor when you are not told directly what is the limiting factor. Okay, so let's move to something else. We'll go to what are the steps that you can take to maximize your profit whenever you are given a single limiting factor. Now, this is the step that we use to solve limiting factor problem. Now, you see your limiting factor may be anything. We are going to be looking at a limiting factor when sales demand is not a factor. That means you want to satisfy all your sales demand, but something else is holding you back from satisfying your sales demand. It could be material, it could be labor, it could be machine hours. Okay? How then can you maximize your profit? Look at the steps. First of all, step 1 is to get the contribution per unit of each of the products. So you see, I mentioned before that for limiting factor to work, there must be multi-products, all using the same type of resource. That means you'll be dealing with 2 products or 3 or perhaps 4, all using the same resource that are scarce. Because if all of them are using different resource, then you will not have limiting factor. They must be competing for the same resource. Okay, first of all, you have to calculate each of these products, their contribution per unit. And that's one point. The second one is you identify the scarce resource. Just the way we identify the scarce resource here. If it is not straight, you identify it straight. The third is, after getting the scarce resource, calculate the amount of scarce resource that can be used to produce each type of product. For example, we mentioned in that first example that the scarce resource is machine hour, and we say the machine hour per unit. Remember we said 5 minutes per unit. So this is the kind of thing we are going to be looking at, or how many units per hour. Like the other time we said 10 units per hour. So we are going to look at the amount of scarce resource that can be used to produce just 1 unit. After getting that, the next stage is to calculate what we call contribution per scarce resource. How do you do that? Numerator, you put your contribution per unit. Denominator, you put your contribution, and you put your scarce resource per unit. So that means you are going to do your contribution in Naira per unit. Let's say your labor hours is your scarce resource. Your labor hours per unit is your denominator. When you do that, what you have is your contribution per unit of scarce resource. After you've done that, you rank the products. You rank the products according to the contribution per scarce resource. Okay, so what do? It means the product that has the highest contribution per scarce resource, that will be ranked as number 1. The other products having lower contribution per scarce resources will be ranked accordingly. And the one that has the lowest contribution per scarce resources will be ranked last. Step 6, construct a production plan based on this ranking. It means that you have to satisfy rank number 1 first and give rank number 1 all the resources it needs. When it has been satisfied, and he said, okay, I need no more, you can now focus on rank number 2 and try to satisfy until rank number 2 say, I need no more, you go to the next one. So that is how you construct a production plan. When you do it that way, you find out that you will be maximizing your production output such that you will not be wasting resources on what will never give you profit or higher profit. Okay, let's look at example 2. Let's look at example 2, limiting factor analysis. We're told here a company manufactures and sells 2 products, X and Y, which are both manufactured using 2 different machines. Now, if you can remember this question, this is what we did in LF1. But the requirement was for us to identify the limiting factor. But now look at requirement 2, because it is exactly the same thing here. The only difference is they have added one thing here, which is contribution per unit. That one was missing in question 1. Then I said, given that machine 1 is the limiting factor, you see, we identified that machine 1 was the limiting factor. Now they are telling you that, assuming that machine 1 was the limiting factor, what is the optimal production plan? That means they want you to do step 1. Excuse me. They want you to do step 1 down to the ending. And what should the company adopt? Okay, let's look at the answer to this question. The answer to this question here . Let's go. The answer to this question. Solution. We said step 1, look for the contribution per unit. We are giving the contribution per unit 7 naira and 5 naira per unit. If you were not given, you will eventually be given the selling price and perhaps the variable cost so that you can find contribution. In case you are not given that, you might also be given something else to enable you to get your contribution per unit. Perhaps they might give you total contribution and total sales demand. And you would just divide total contribution by total sales demand to get your contribution per unit. Either way, that is the first thing you will do. Get your contribution per unit. The next thing is to get your limiting factor per unit. Now we said 10 minutes for 1 unit. 10 minutes for 1 unit. Okay? Now, what happened? How do you get your contribution per limiting factor, which is the next thing? Contribution per limiting factor. All you need to do is your contribution numerator, your limiting factor denominator. So you simply say 7 naira divided by 10 minutes. It means 0.7 naira per minute. The same thing you do, the second one, 5 hours, so 5 naira divided by 6 minutes per unit gives you 0.8 A3. So which one will you rank first? The one that gives you the higher amount of contribution per limiting factor. And so you rank that as first. So product Y will be ranked first, product X will be ranked second. It means that when you are producing your production plan, you will need to satisfy everything in unit Y first, product Y first, before you go to product X. And so look at what it takes. Product Y is ranked number 1, X is ranked number 2. Look at your sales demand for product Y. We were told that sales demand for product Y is 15,000. Okay, 15,000 units. So that's this 15,000 units. Now, how many hours can go in 15,000 units? Okay, look at what we'll do. We said 10 minutes for 1 unit. So if 10 minutes is used for 1 unit, how many units can go in 1 hour? We said there are 60 minutes make 1 hour. So 60 divided by 10, it means 6 units will go for 1 hour. Okay, if 6 units will go for 1 hour and you have 15,000 hours, 15,000 units, how many hours will we take to do them? If 6 is for 1 hour, simply say 15,000 divided by 6, supposed to give you 2,500. Okay, I'm getting it twisted. Sorry, I'm getting it twisted. Look at it this way. You have 6 minutes is what we are doing. I don't know when I went to do X. We have 6 minutes per unit. If it is 6 minutes per unit, it means in an hour, you have 60 minutes, make 1 hour. That means 60 divided by 6. It means 10 units in 1 hour. 10 units in 1 hour. If 10 units for 1 hour and you have 15,000 units, how many hours would that be? 15,000 divided by 10. That will give you 1,500. And that is one way to get it. The second way to get it is this. We need 15,000 units to be produced. And we have 6 minutes to make 1 hour and to make 1 unit. So how many minutes are we going to use? It means 15,000 units multiplied by 6 minutes will give you 90,000 minutes. How can you convert 90,000 minutes to hours? All you do is divide by 60. So 90,000 divided by 60 will give you 1,500. So that's it here, 1,500. But we said our limiting factor is machine 1. And machine 1 has available hours of 3,000. 3,000 is the maximum available hours, and product Y is taking only 1.5. That means it has not exhausted all the limiting factor. That means if we have total of 3,000 and 1.5 have been taken away from by product Y, it means 1.5 will be available for product X. So can you see the arrow going backward? In product Y, the arrow was moving forward. We move from left to right. But when you have reached the limiting factor where there is shortage, you go from right to left. So it means that if we have 1,500 hours remaining for product Y, then for product X. If we have 1,500 remaining for product X, okay, how many are we going to do if we take them 10 minutes per unit? So what do? 1,500 hours, convert it to minutes. All you need to do is multiply it by 60 to become 90,000 units. If it is so sorry, somebody was stopping my line. So sorry, we are used to network problem. Okay, now I was analyzing that. How do you know that it is 9,000 units that you are going to use? It's either you do it this way, 1,500 remaining, that's the 1,500 hours remaining. And we want to know this 10 minutes per unit is equivalent to 6 units per hour. 6 per hour. And it means that if you have 6 per hour, you have 1,500 hours multiplied by 6. That will give you 9,000. It means 9,000 is what you can do. Or do it the other way. 1,500 hours available. Convert it to minutes by multiplying by 60, because 60 minutes make 1 hour. You have 90,000 minutes. And if your product is taking you 10 minutes to do one, you simply divide by 10 minutes, you have 9,000. So it means 9,000 is what you can only do for product X, as against 12,000 that you were given. Okay? So now what will be, the question still says, what is the optimal production plan? The production plan is to do Y 15,000, X 9,000. Now, and hence find the profit. Find the profit. They say that is production plan which maximize annual contribution and hence profit. So let's look at the profit that they will get, or total contribution. It means if we do Y 15,000 units and it is contributing 5 naira per unit, 5 times 15,000 simply give me 75,000. Then when we get to X, we are producing 9,000 units, contributing 7 naira. 9 times 7 is 63,000. You add these two up, 138,000 is your maximum contribution you can get. Okay, So what should the company adopt? The company should adopt making product Y first. After satisfying product Y, then they can look for product X to satisfy using the available resources of machine hours. Now let's look at question LF3. Now look at LF3 now. Question LF3. A company makes 4 products, A, B, C, and D. Now, these 4 products are using the same direct labor workforce. So you see, they're going to be competing for attention. The company has no inventory of finished goods. Direct labor is paid 12 naira per hour. So this is how much you pay for 1 hour. To meet the demand, the sales demand in full, that means look at the sales demand here, annual sales demand. We have 4,000, we have 5,000, we have 8,000, and we have 4,000. They said to meet the sales demand in full would require 12,000 hours of direct labor time. That is what they are asking you. They told you that if you want to meet up all this demand, you need 12,000 hours of labor time. Only 6,000 direct labor are available. You need 12,000, and when you check, you have only 6,000. There is a shortage of requirements. So there's a shortage of availability. So that's a limiting factor, labor hours. So what you do is to work within these 6,000 hours that you have. Is to work within that 6,000 that you have. Now look at the budgeted data for the company. We've read about the annual sales demand. Look at the material cost. Look at the labor cost. Look at the overhead cost. Look at all of these. Now I want to tell you something here now. Let's look at this. Labor cost is 6 naira. And you are told here, labor is paid 12 naira per hour. If they are paying 12 naira for 1 hour, and in product A, they have already paid 6 naira for product A. That means how many hours did we use there? 6 divided by 12 naira. It's 0.5 hours. Product B, we paid 12 naira. So you simply say 12 divided by 12. That's 1 minute, 1 unit, 1 hour per unit. Product C, we've already paid 3 naira. So you say 3 divided by 12, it means 0.25. Then D, we've already paid 9 hours for labor. 9 divided by 12, 0.75. That's the most important thing there, because you need to calculate the labor hours per unit. That is the scarce resource. You were not given contribution, and you were not given the limiting factor per unit. So you are the ones to find it, and you are asked to calculate the optimal production plan. So see what we did here. First, we need to look for the contribution. Now, you are given direct materials. Look at the direct materials here. Direct material, direct labor, and variable overhead. So these 3 lines here will need to be filled up here. Direct materials up to variable overhead will be filled up here. When you add them together, you have your variable cost per unit, because the figures you collected were all in per unit terms. Okay, you have your variable cost per unit. Now the next thing to do is to get your selling price. we are giving selling price. So notice we have ignored fixed costs because we want to look for contribution per unit. So this is your selling price. So you simply say selling price minus variable cost. So all we are doing is 15.5 minus 11. That gives me 4 naira 50 kobo as our contribution. The other one is 7 naira. The other one is 2.5. The other one is 9. These are our contribution per unit. That is the first step which we've taken. Second step is to look for the limiting factor per unit. And I've told you before, they gave us the labor cost for product A, for product B, and for product C and D. And we are told that direct labor is paid 12 naira per unit. So simply say 6 divided by 12, 0.5. 12 divided by 12 will give you 1. 3 divided by 12 will give you 0.25. And 9 divided by 12 will give you 0.75. Now, this is your limiting factor per unit. So what do you do? The next thing is to look for your contribution per limiting factor. So it means that your contribution is for product A is 4.5 divided by limiting factor 0.5. So 4.5 divided by 0.5 is surely going to give you 9. And so 7.0 divided by 1 will give you 0.7.0. 2.5 divided by 0.25 will give you 10. And 9 divided by 0.75 will give you 12. So when you've gotten your contribution per limiting factor, what do you do next? You rank. You rank. Which one is the highest of all these results? It's 12.0. You rank him first. Which is the second? It's 10.0. You rank him next. Which is the third? It's 9.0. You rank him third. And which is the last? It's 7.0. You rank him fourth. Okay. After the ranking, the next thing to do is to do your production schedule. Your production schedule, you put the ranking and their products. So it's DCAB. So you'll go back now to the demand, sales demand. D is 4,000 that is required. You need to see how much of D you can satisfy before you go to C. Can we satisfy the whole of D? Let's see. If D is 4,000 sales units and the labor hour is how many? 0.75. It simply means we have 4,000 multiplied by 0.75. It means the hours required is 3,000 hours. 3,000 hours. Of course, that is smaller than what is available. What is available is 6,000 hours, but you have been able to see 3,000 hours. Beautiful. Let's get to the next one, which is C. C, we need to do 8,000. Can we do it? Let's see. 8,000. So look at it here. C is 8,000. And if you have to take 8,000 multiplied by 0.25, this is your direct labor hour per unit, 0.25, to give you 2,000. That means you need 2,000 hours to work product C. Would that bring a shortage or will it bring a shortage? No, because our target is 6,000 hours, which is put at the bottom. But we've met 3,000 and we've met 2,000. We need to get everything enough to give you 6,000. Let's get to the third one, which is A. A, the See A? Okay. A, what is the number of units? 4,000 units. So you ask yourself, if 4,000 units is to go at 0.5 hours per unit, 0.5, it means you need additional 2,000 hours to do A. But what is now remaining is 1,000. So that means you cannot fully do A. You have to do A as much as your 1,000 can carry. So it means 1,000 here, you're not going back. You now 1,000 hours, taking it by dividing by 0.25. 0.5 will give you 2,000 units. So it means out of the 4,000, it's 2,000 that you can do. So that will mean that B, since A, B, and C are satisfied this 6,000, that means this B can no longer be satisfied. That's why you are seeing 0 hours remaining or used up. Sales will be 0. Of course, you know their contribution, you put their contribution and multiply to get total contribution. We'll now go to question LF4. Let's see. A company makes 4 products, X, Y, and Z, using the same item of direct material in the manufacture of all 4 products. Budgeted data for the company is as follows. And this is the budgeted data, W, X, Y, and Z. And we have our annual demand as before. We look at our material, labor cost, variable overhead, fixed overhead. Now we are not told what is the limiting factor. We are not told yet. Now, they said due to restricted supply, only 78,000 naira of direct materials will be used during the year. So you see, this is 78,000 of material. So all of them are competing for the same material. So material is the limiting factor. Now that's going to be an assignment for you. Identify the quantities of production and sales of each product that will maximize annual profit. So what will you do? You need to look, we have identified the limiting factor as material supply, not quantity of material. Material supply, 78,000. So material supply is in naira, and that means direct material costs will be the limiting factor. Direct material cost will be the limiting factor. So first of all, identify your contribution per unit. How do you get it? Is this direct material cost, direct labor, and variable overhead? So let me take that of W and do it. It means we have 5 plus 4 plus 1. That means variable overhead is 10 naira. And look at your selling price. Selling price is 50. So you simply say 50 naira minus 10 naira gives you 40 naira. So 40 naira, that is your variable contribution for W. You do the same thing for X, Y, and Z. 40 naira is your W. So what you do, you have identified your contribution per unit, 40 naira for W. What is the limiting factor? The limiting factor for every of them is material cost. So this 5 naira is limiting, this 4, this 8, and this 6. They're all limiting factor per unit. It has been done for you. So what will you do? The next one is you look for your limiting factor per scarce resource. So we said 40 naira, which is contribution, divided by limiting factor. Limiting factor is material, which is 5 naira, divided by 5 naira. That's 8. So 8 naira per direct materials. So that's how you do it for W, X, Y, and Z. Then you look for how to rank it. After ranking it, you now look for how to check which one of them will give you the highest productivity. So which one of them will be produced first, produced second, third, or fourth. So far, so good. We've come to the end of this chapter. We've seen limiting factor, and we've learned that in limiting factor, the examiner is going to give you only one limiting factor affecting the product at the same time. If it doesn't tell you, it will give you how to identify by checking your requirement as against what is available. If there is a surplus, no limiting factor exists. But when there is a shortage, then you know that one that has shortage is the limiting factor. So if there are 2 or 3 having shortage, the one that have the highest shortage is the limiting factor. Now we've done that, you now do your ranking. After identifying your limiting factor and your contribution, you do your contribution per limiting factor. Then you rank. After ranking, you produce according to the demand of your ranking. So thank you so much for coming to class today. Thank you so much for the time and attention you've paid in this class. In our next class, we are going to take something else that has to do with marginal costing decision making. I think perhaps that will be on Monday when the next MI class will be holding. We'll be looking at some shut down or make or buy or other short-term decisions that management has to make. If you have any question here, please feel free to ask in the chat room, and I'll be glad to provide answer at my spare time. Thank you once again for making this class a fruitful one. I want to wish you a good night's rest. Thank you so much.